Hello. Okay. So let's start the CSCI 310 cybersecurity. And for this lecture, actually is a really long part. Is introducing the malware. Okay, so the coming malware, so you will see is a plenty of the slides. So for the coming lecture, like after the spring break, I try to like start the introduce some background, but um you may be some curious, but don't worry too much. Like if in your quiz, like say it's a midterm, so time limited. So I'm not really like focused on this part, including the malware. So don't worry too much. And you have an assignment, so will be due by this end of March. And you need to choose like just like go to a little bit about your assignment. So you need to choose like one of the malware you're going to study and then you want to like focus on. So you're not limited. Okay, of course that you think you're be interested. So I think it would be a good practice. Because this will have from students' feedback that they pretty enjoy, like if instead of like listen from the lecture or just like give you some definition, because you see it's a really long slides and like you're going to cover using 3 weeks, okay, to finish the all the lecture. So also when we do really worse, and then we can really dive into details. So I wish like from your really like real case analysis. So like when you introduce some backgrounds, like how we like start, let's say ransomware, and then at least give me a study like from actual um, um, things that really happen, affect like what kind of damage or destroy, or the what's the vulnerability, what's the risk. Okay, so if we try to figure out, and then what's the impact of this malware. Okay, maybe how it affect like financial loss or like some reputation or any other consequence. Okay, maybe to this society or to the world. Okay, and then of course like the major part is like how can you pull some like protection mitigation. Okay, so what's the prevention? What kind of post like remember, and then maybe some like possible how can we do the detection, response, recovery strategy, risk management, all this related to the lecture. You don't have to wait too long. Okay, just less than 1,000 words. Okay, so at least it's a good practice for you to like getting more familiar as a beginning of cybersecurity. Okay, we need to know have some idea what some area. Okay, so I give you so much. Try to give you enough time. Okay, so hopefully it'll be enough time for you. Like we actually analyze it almost like by the beginning of the month. So at least you have a month to write it and prepare for it. Okay. And next time move back to our malware. And for today is I will be try to like go through some background introduction, and then of course we try to introduce certain malware, but we cannot cover like all the lectures. Okay, so for the malware sometimes we call it also malicious logic. Okay, in behind we have certain types, so sometimes maybe a Trojan horse. So if you know the history, like what this Trojan horse come from, if not this mainly is you know, so they just like they pretend that they surround and then they send the children, the horse like the woodman and all the soldiers like was like hiding inside this like horse. Okay, the woodman make a horse, and then during at night when all of them like resting, and they just like come out from the horse. Okay, so that's the idea. So it's like the key concept is hidden. Okay, so they wait until you're not aware, you're going to like execute. Okay, in the bigger, and of course sometimes you see a lot maybe the computer virus worm. Okay, but for the definition, sometimes what's the difference between virus was a worm? Okay, we'll talk about it, and then also the other types are going to happen. Okay. And in the theory, okay, so the abbreviated programs, so are they being virus and disabled? So we can like, ask this question. Okay, but it's just the beginning entry. But when we start to study more, like as far as when we have a class like about malware analysis, then we have a better we'll dive deeper. How can we like able to determine or think that potentially they are malicious or the malware? Okay, and how can we provide some like possible defenses? Okay, so based on the property of the malicious logic, also the create the trust. Okay, so that's we're going to move on. So all this like malware will be, we say, is a set of instruction. It causes like the site security policy to be valid. Okay, it's possible. Not only the site, also the system itself. Okay, so it will be a statement. Yeah, so sometimes they will try to do the hijacking. Okay, touch on in the lower level, but of course, like in this study, we are not really saying how deep or how they touch the kernels or in machine language level. Of course, we are not really dive that deep, but for this one, we need to recognize different type. Okay, what's the behavior and how can we prevent it? Okay, so sometimes that we in the lab, I will try to give you some my source code, no matter in Python format or JS format, because I keep switching say in they're all example, because in different language we can pretend and write, or like based on the platform, like let's say system. If for Windows, maybe we will try to write some like exe, the binary file, executable file, okay, or maybe a Unix file. So there's a certain script. Okay, so they called the ls, the list script. Okay, in the list script, so right here is like copy, and then Simon, if you remember right now we changed, if you remember the operation user. Okay, oh, what's that, what they were presenting for the execution? Okay, special bit, and then we move the list. Okay, ls, and then they will try to get away. So they will try to sometimes paste the program because the ls, and then track someone in executing it. So right here, so it's called a like set UID to them shell. Okay, right here. So that's how we create. So we start to like copy from the temporary file and then copy, so they get executed for like others. Like that means the global. Okay, of the UID, and then use a sticky bit. Also, some is a way we can do. Okay, so you can see even for malware, some we call the different type like progress to or like the worm. So in behind they will just execute certain commands, right? So it's the same idea. Of course, the sample code I gave you is really obvious, or like you say, it's not harmful. Sometimes yes, for certain program it's not harmful at all, but depends how you use it. Okay, so there's a idea, and right here we have like so many types of the malware, so including the virus like crypto malware, ransomware, and worms, Trojan horse, root keys, keylogger, malware, spyware. Okay, and then cryptocurrency miner, botnet. Okay, so but of course, each of the time we will discuss it and then show you what they looks like, and that as a history. Actually, you can just think about like once we have the um when we have get our first really early computer, maybe in the we did like programmer for the Apple II, so they wrote something. Okay, so they at that time they maybe not really called virus, but very like experimental. They want to test it. Okay, the first cohort. So this one is the students, which is student like we described that. So teachers name it computer virus. Okay, so they will test it on the Unix system or something. So what is the idea? So maybe started the virus, the first hit, and then the worm or 2 days, and continues to attack and infect some like PC. Okay, so all the threats like faced by the user. So each year will be defined. So with one significant virus. Okay, like this Palestinian brains, or one of it, the first virus happened on the IBM PC, and then later the Stone. So it's the boot section virus initialized. Okay, and then later that Morris worm. So in 1988. So it's another one like force worm. So all these like, or like later in the disk killer. So all this like, of course nowadays we have like this one of a really crazy one of cry encryption, like this cryptographic after the cryptographic, or like on miner. So all this you see In this history, it always happen, and then that's why you see the cybersecurity that never fail out, or like when we have new system, introduce some new software application, then we create the new. That means we always have threat. Okay, so we need to how can we prevent it? So this and step one is probably the Trojan horse. So it's like in behind how does it work? So the program will be override. Okay, override the purpose. Okay, so we kind of like known to the user. Okay, and convert the purpose. So unknown to the user. So that's why we call it Trojan. Okay, so it's a really long time ago. And then there's some of course some previous script is the Trojan horse. Okay, so mainly they may be some in examples. So let's say if I try to create the files in the directory, right? So but this time originally, so you just want to list the file, but this time it changed the set UID in the shell. So here's the change idea. So if I give you the file like maybe in Python script or no JS, okay, JS script. So originally, okay, I give you just like maybe display a picture. In behind, maybe I try to create a function. That function, I try to read your content, send it back to like to the server, create connection, wherever, or like delete all your files, or try to walk through all your lists and save it wherever anyway. So this is called a Trojan horse. That's what you need to know. Okay, so it's the idea. So it comes as the first one. So you know the reason because really popular. And even nowadays, I would say lots of time they just change the packing, they change their format, but always in behind the idea always the same. Okay, so maybe sometimes they will let you to download a software application. Sometimes you do have a application can download from the official website, but sometimes people they share it to the GitHub. Sometimes they post it to other website, upload you can download. Okay, but you never know. You cannot validate. Okay, as a regular user, normal user, you have no idea then. You just download and install it. But sometimes they when they try to like unpack it or like convert it, sometimes we call it reverse, right? And then they try to inject certain functions like add the statement and then pack it again, change the binary, upload and share to everyone. Then it causes a problem. It's called a Trojan horse. Okay. And then we talk about this one a lot about the backdoor. Okay. So backdoor it yeah, avoid some normal login process. Okay. So we try to let the backdoor open. So always they try to do is they the malware try to like, install it. Okay. Okay. Some malware they try to exploit their backdoors so it can create other malware. Okay, so by a certain way, it's like once I able, like maybe the Trojan was okay, and then they inject it, and then after execute, okay, maybe in the beginning you have no idea, but actually in behind it try to open the back door, like certain maybe your port number, set up the remote file. So when you create the back door, then I can because there's a memory they allow for those to send sending certain commands, sending the some install certain program, create certain files away. So it can like create something more. And some program, so we know have some accidental like backdoors. Okay, so maybe some old version of Linux kernel, so they also include the backdoor. Sometimes the benefits like backdoor for good maintenance, like for the developer is like in purpose or somehow they didn't figure out. So those are malicious software can have a backdoor as a part of the app. So can be do like this. Sometimes they can pretend like as a free game. Okay, maybe they include the malware. So more pretty common if you're the Android user, you know, like Android user, you can always download some certain we call the APK file. Okay, certain file. And because some user they don't want to upload it to the Play Store, you know, for iOS, it's compulsory. You have to like subscribe as a developer, pay for it, and upload all your files. Okay. Long time ago, you can still like jailbreak, install some file by yourself, but nowadays you have no way to do that. Apple, they do have really like strong control in it. And for Android, because there's one way to like bypass the App Store, because some people, okay, after developer, they you don't have to really subscribe, but you after you create the app, okay, develop an app, then you can just upload it online, you can share APK file. So once they download it, they can install it. So the one of the reason, if it's a free app, then it won't affect. But sometimes if they need to charge, then the Play Store and or Google, they will like charge you. So some people, they don't want to pay for it. So that's why they share it. Some people you have no idea when you download the APK, then you got trouble. Okay, so also maybe some like private software, so maybe they will like modify and provide the backdoor, so it's possible. So always like free can be the entity alludes to unsuspecting, so it's kind of the idea. So sometimes like when it's free, it's not really free, so you have to like pay back or something. But the keyword I backdoor, like sometimes we will say create a backdoor. So here's the idea. Okay. So sometimes we create a port, create some certain connection. Okay, you are not aware of it. Okay, and it causes remote problem. And as a follow-up, then we will have some called a remote access children. Okay, we call the web. Okay, so it's a name. So what's the web is going? So it can have some like called a remote administration tool. Okay, or we can have automate battle. So there's a combined battle administrative control of the host. Okay, so maybe the malware can be installed the server service or host. Here will be some like keywords, maybe server, right? So service will be running certain programs, and the host, okay, maybe your local host or whatever, server host or whatever. So the attacker can connect through the remote software. If later, if you're like still taking the malware analysis, you in doing we sometimes do the static analysis or dynamic analysis. So we try to execute, and then we try to check the connection to the internet after you able to connect, and then after you execute that the malware. Okay, so it will try to check the connection, and then once it has a connection, we say they will create the file and then set the backdoor. So when the attacker is sending the certain command, so they can read your files, modify or create certain program. So that's how like. So possible way they can control your devices, including like they can maybe lock your keystroke. Okay, what kind of thing you did type. So if I know you say log into the bank account, then I know like what's your password. Or sometimes I can take the screenshot. Okay, as a follow-up, if you're being injected, if you perform something, how to use your personal computer, and they will take your snap your screenshot. They also sometimes they control your webcam and then say there's a video, all these things, and then they can do the ransom. Okay, so you see sometimes like for the malware or something doing something illegal, they are like working together. Okay, so they are like used as a pair, and they may be like copy certain files. If you let's say if you from the example I walk through all your like OS directories and then subdirectories, and then I can copy all this file and then send it to my server. So still okay. Also, I can embed other malware too, so it cause like some like chain problem like this. Okay, so this one is called a remote access Trojan. So including, so one thing is like it include the backdoors, okay, and also control your host, okay, your host, the local host. Gemini is the one designed for the Android cell phone. So when you paste it on the Android market for so like this. So when the app was run, so it will like install itself, and then it will use some several techniques to make it hard to find. So then it also try to connect to the remote command and control server. So this one is what we're saying, and then it will wait for the command. Okay. So once it receive the command, so we're going to execute. So it will maybe delete your SMS message, and then also they will send your SMS message to your remote server, or sometimes they are allowed to like dump the content list, dump the list of apps. So how serious is it? Just imagine it. Okay, if you they maybe know you have certain bank account, they need to receive your OTP. Okay, they receive it. So once they just like take your one-time passcode, and after they receive, which I'm saying to the remote server, and then delete your local OTP. So you have no idea like when did you receive it, but they already obtain your OTP, and then based on this OTP, they are able to like, log into your account. Let's say your bank account like this. So you have to like be careful. So when they especially what you say for the Android, that means the Android platform. And then next one will be the rootkit. Okay, for the rootkit will be the tree holes for the like, corrupting the system. Then we can cover some like convert action without detection. So it's a rootkit. Okay, so in the earliest one, so we will like install some like backdoor. That's what we say. Okay, and then so the attacker can like enter the system, and then they can corrupt the system program. Or also they can hide their entries or action. Okay, so they can create something and hidden it or remove it. So you are really hard to lock it. Okay, and the programs to list the directory, say the content, and then we can alter it. Okay, so they're not include certain files. Also, it's possible. So as a basic like beginning, I give you some examples. So how can I walk through the all the directories, right, and check the files, and then later I can just say, okay, don't check those certain files. It's possible. Also, the network status program, so also can be altered. So it can let us to the high source and connection for from specific hosts. Okay, and you will never able to see, okay, it connected to a certain server. And of course, in some malware analysis, like as well as say, we try to look, search or study those like they already know they're possible, but for like advanced level, it's really hard. So it really still in this industry, in this market, we still like working on it. Okay, thank you. And Linux like rootkit, right here, so it's one of the example. So they will try to replace the system programs. So they may like refer is that person. If you know you have the idea the LS file GU, so they're using for the file system, okay, or PS Tom or Lazarov or the QO for the process account contact to hide the rootkit jobs they can use, and they can like replace it, and then the login, and also others allow the user the attacker to log in, also activate the super user privilege, like if you know the sudo or something, so they can suppress any logging. Or next day, so I have config to hide the presence of the attacker or the TCPD or system log, or this they can inherit the logging. So all this. So the way is that they try to replace all this existing system program. Okay, and that means they change it. And when you try to list LS, right, list all the directory, but they will try to hide their own created attacker created file. So you never able to see so of the tree. So they will add back some like backdoors so that the attacker can log in unnoticedly. So it's a possible. Also, they can add the network sniffers, so they can gather your username, password, or other like login information. So all this will be have a similar rootkit exists from for other system. Actually, it's true. Like not only the this one we say the Linux, but of course like Windows or others like it's possible. And what the portion of defenses? Okay, so of course they use some non-standard programs. So they will try to like use those non-standard program to obtain the same information, and that the standard one like should. Okay, and also then we try to compare. Okay, so maybe the list LS list will they will be listing the contents of directory or direct dump. Okay, they are dump. So it's a program to read the directory entries. So that was like non-standard. Okay, so maybe we will try to like compare the output to the LS. So if they are different, that means the LS will probably like compromise like this. So you can try to compare. Okay. And then also we try to look for some specific string in the executables. So maybe they would do the analysis. So for the programs, well, yes, usually they're not like rigid, but we cover easy enough to write your own. So it's kind of like this. Also, we try to look for certain change using the cryptographically strong checksum. Okay. Um, maybe you have no idea what's the checksum. So in the later we will like when we move on to the cryptography, so we have a better idea. In this moment, it's like we know the checksum. Also, the maybe work like they try to bypass the system program, right? So maybe they use the system directly. So that's why. And then next step, maybe they will try to like alter the kernel. So it will be structured if you will like learn operating system, then you know what's the kernel like in between the really low level hardware, and we have the kernel to help us handle, and then the application will be the on top. So the application will be the program we have written or some like executing the files. Okay, so we will pass it to the kernel that have it to handle it. So most are pretty common is the system call. So the rootkits, they will alter their system call. So using the some like kernel lowerable module, okay. And thereby, so they try implementing the effectiveness of the early defense, okay. So like this, there's some like they maybe try to like modify your entire the system call. So maybe right now in this moment you have no idea what's the system call. Sometimes we have the DLL to call it, and of course like when you learn more you have more idea. So so they will call in the system call table, so they involve certain version, new kernel lowerable modules, and then they will hide the presence of it. Okay, so it's possible. So maybe we can try to compare the system coordinate tables in kernel. So where they copy from the boot time is possible. Okay. So or we do have some more like maybe point like try to change a variable in the kernel. So upon the system call. So it always point to a modified table defeating it. Okay, so it's possible. And also maybe they will modify some virtual file system layer. So they will hide the files, right? For example, case the UID, group ID, or manipulate some like process or some like pseudo files to control the process monitoring program before too. So all these will be possible. And then they try to take the advantage of the ability to access the OS entire like the process through the file system. So all this they're doing. And slightly we have more like really long time ago this one story so pretty interesting. I say is the Sony like BMG. So the try to develop a rootkit so they can implement the DRM on the music CDs. Okay, so that one only works on the Windows system. Okay, so they need to install the program to play the music. So once they install the software, they will add the function of the Windows OS. So they will prevent playing the music using other program, and the software conceals like itself by altering the kernel. So they'll not like list any file or folder beginning with like this system, and then they will store the software in those such file. So once they when you put your system, so the software will contact the Sony and then get the advertisement so the display when the music was playing, so like this. So once they make public, and the attacker can create a Trojan horse, so they in the beginning with the analysis like this. So it's a big problem right here. And then replicating the Trojan horse. Okay, so this one like also can make a copy of itself. So it's called propagating Trojan horse. So in the early version and some maybe some animal games, they use it to delete the copy of itself. And it kind of like hard to detect a long time ago. So maybe later they will try to recommend like suggesting they need to modify a compiler. So including the Trojan horse, so to like copy itself into a specific program in the later version of compiler like this. So here's a study. This one is called a Thompson compiler. So how it works. So it tried to modify the compiler. So when it's a compile login, and then login will accept the user's correct password, right, or fix the password. So kind of same for the one for all the user, and then it will try to modify the compiler again. So when it compiles a new version of the compiler, so there will be some extra code. So they do the first step, so automatically like insert it. So once they will recompile the compiler, okay, and then they will delete the source, like container modification, and put the undotted source back. So here's the idea. And so in the beginning, so in the beginning, if you as we say, we have the login source, right, and then we try to pass the correct compiler, and then we will input the user password, and then we will try to go through the login executable, and then after you pass it, get the true, and then you're able to log in. But after they modify the compiler, they will call the compiler. So right here, you can use any user password or some magic password, whatever it doesn't matter. So after you pass the login executable, you can log in anyway. So you can always get in login. So it's the login program. And then if you look at the compiler, so maybe like for the compiler source start from the beginning, so they will try to use the correct compiler, right? And we will pass the login source, so they will change the compiler executable, and then with the login, just like give you a covered login executable, okay. But if we already modify the compiler, so even we pass the login away for anything, so after this compiler execute, we also will retrieve the login executable. So here's the idea, like how it works. And also, another one's like the comments, when it can be like the pains they taken to ensure the second version of the compiler. So it never released. So finally, so it deleted when the new compiler execute from a different system. So they overwrote the daughter compiler like this. So right here, so we know no amount of the source level verification, or the maybe how can we report it and just code. So it's really hard. Maybe we can, once we have the source code, yes, it may help, but it always not able to ensure our safety. So it's really hard to detect the malware. Okay, so far we'll be talking all the based on the Trojan's horse. Stuff from the traces, I follow up that. Some like code related, we create the backdoors. Okay, yeah, the rent. Okay, also the Trojan has to deprecate by itself. Okay. And next will be the computer virus. Okay. Computer virus will be the program, so they will insert itself into one or more files and perform the same some action. So it's a virus. Maybe they will in the insertion phase, they will inserting itself into the file, and then in the execution phase, they will perform some maybe now action, really doesn't matter. And then in the insertion phase, they must like present right here. So they're not always required to be like executed, and then the virus can insert like in the itself into a boot file, so only like the boot file not infected. So like this. Then maybe you ask a question, okay, then can we treat the Trojan horse, like is it a Trojan horse or not? In certain stage, yes, you say like you try to like infect the program action, and then it will like later we create certain action infected and executed. But for the purpose, like for the virus like action in the beginning, yes, it's like doing, but in terms of maybe nothing, none. So it can be like symmetric, but philosophical like differences right here. So maybe when we do a defense against the Trojan horse, also inherit the computer virus. So it's possible. So sometimes like it may confuse you. And then as well we say long time ago, look at history, so we know that from the Apple II, right? So at that time we are not really called virus, okay? So it's more like it's for the coherent. So that's what it did in the system we are saying. So with it, then the experiment. So the goal is they want to get the super user privilege, okay? So they try to set the time, maximum time, minimum time, so FH. Okay, the virus is really pretty small, so they're not like degrading the response time. Also, like they can when the virus they attack, so they can like be moved like quickly. Okay, so in the Unix system. And then for the next one, after you're able to get the privilege image, they want to spread it. So they want to like implement this really simple security property. Okay. The bell lapadola. So like this, or they also they want to like waiting for some no not inhabit. Okay. So maybe they let the virus like to like, spread easily. So it's also in their experiment doing. Um As a first like report, so we say that report about the virus. So you see in the history, so written for the IP and PC. Also, they will enter the boot setter of the 4P. So maybe nowadays you have no idea what's a 4P. It's a smaller, like more like it's a square shape, so you can put it in. So the storage is really small. Maybe like some start with like maybe start from the generation like some kilobytes or later like several megabytes like this. Okay, so it's a kind of historical things like almost like it may be still using 20 years ago, so but not right now. Okay, and then the map is virus also is like it's written on the message tools, so it's like for the Apple's program. So they would try to print the universal message of a piece at that time and then delete itself. So it can be the virus. And so I think there's some more like reports or some like virus based on Unix system and then spread to like 46 systems and also something like this, or like Lotus like 123 virus. So it will store set of comments in the spreadsheet, and then they will try to load when the spreadsheet open. So when you open it, so they will change the value in a specific row or column and then spread to other files. That's like how it looks like. And for the infection vectors, including the one thing you will see that we call the boot setter infectors, right? And then we have an executable infector and also the data infectors. So they're not really say mutually exclusive, but some virus will do like 2 or 3 of this. That means like they can perform all of this, like they will change the processors, executables, and then the data, or only they just like working on the executable data, whatever, or data, or put an executable. So it is not really say come with this. And kind of like try to like last part. So we have the processor of this like finish like and the processor will be the virus, so they will like insert itself into the processor of the disk. So we say we connect the code. So once we try to execute, they will look at the disk, right? So when you put in a program, then kind of apply. Let's say you turn on your Windows, right? So how can the system know like where to get your Windows system? You know, like in the memory. So like this part of it is saving the Windows somewhere. So they need to load it. So we say, this one of the branch drivers is like example, they try to move the disk interrupt vector. Okay, so here's a location like 13 H to 60 H. So they will set a new interrupt vector. So involve the virus. So once they insert the copy, okay, they'll know they will check it. Okay, the location and 1, 2, 3, 4 H and the location for. So if not there, so it will copy itself on the disk after the saving the original boot log block. So if there's no free space, maybe it doesn't infect, but if it does have a free space, then it will infect them. It will just overwrite, use this space. If they just like jump to the vector at the 60H. So how are you doing? This is how it looks like when we have a header and then first program they're executing and then one execute. And we have some like instructions and data as a follow. Okay. And once like after infect with a header, so they will jump to like from here execute, they jump to the beginning of the virus. Okay, just like continuous. Okay. So after you finish complete, they will turn back to the program and execute. So maybe you have no idea. Okay. So well, here the virus can infect the executable files, though not only exe.com or on the PC, or like also they can append itself. So to put itself like anywhere. So it's possible. And then also they can like, for example, the bundle, so it can execute at any point. Okay, so it's possible. And also the after boot, then we have the executable infector. So right here, maybe one of the here the virus, maybe you check like if the system is infected. If no, they will have the response to request the execute file, and then they will check the date. So if not the date, they will set up the response to the clock interrupt. So they will run the program. If no, then they will set destructive threat and then delete no infected all the files. So this is pretty common for the virus. They will check it, and then they will check all the cores. They will call the files to execute. If they are not doing nothing on it, or otherwise they will infect or just delete it. Okay. If they receive a certain error that doesn't get any signature, so when they execute it, so they will just doing so the executable will contain state with infected. So we keep doing this. Okay. So kind of explain like for the computer virus, and then we have the macro virus. So this virus are composed like as a sequence of instruction. So it will like interpret like what they execute directly. So it can like infect either some executables, okay, or some like data files, okay. So it kind of like dependent on the machine architecture. So most of them tend the effect will be maybe the machine dependent, okay. So not really depends on the architecture, but they will really maybe work on the machine itself, okay. Alicia, so this one is like working on the work. Okay, so it will not only the Windows but also the OS system, so both of the work. So also it try to involve the program, so open the infector file and it will install itself. So they open the macro. Okay, so they will copy itself the normal template. So this way, once like you have some infect any file, they can open it in the future. So so also they will like involve in the mail program, so it can sell itself to anyone in your address book. Okay, so they can use the mail program. Okay, then the Mac OS the user they're not using, so that's why maybe weird to the Mac OS user. They have no idea. Okay, also we have another like the multi-prioritize virus. So this one will be either like in fact the push set or executable, if you remember like free tab like, and then typically there are two parts, including one part will be on the push set, and another part will be working on the executable infector. That's how it looks like. And then the concealment. And concealment will be like they try to terminate and state the precedence like TSR, and then state encryption, polymorphisms, and metamorphism. All these will be included. And for the TSR virus, it will be just like it's a virus that will be like stays like active, okay, in the memory. So after the application is like completed, so maybe like bootstrapping, dismantling, all this. All those are non-TSR virus, they maybe only like execute. So when the whole application is like executing. So here's an example. So once they stay in the memory after the program like or this month is completed, so they're still like. And Steve virus right here will be like conceals the infection of the files. So one is called the IDF, right? They will modify the DOS service, okay, and they will interrupt the handler. So in the beginning, they will try to request for the files link. So they will turn it uninfected file links, and then they try to open the file. Okay, they request to it, and then temporarily these infect files, and then they will re-infect on closing. Okay. So later after they load the files for execution, so they'll load the infected file. So that's how it looks like. And when you look at it for some like encrypted virus, so they can for a virus they can encipher, except there's some small decipher routine. So when we try to detect a virus by the signature, so it will be harder because like they will hide it. So let's say we fill a virus code and then they go through some like decipher routine and then encipher the virus code together, and then they convert that decipher key. So it's really hard to do that. There's some example right here. Let's say the decoding code right here is 126 bytes in the beginning as a register. So we have Q1 to like go to register AB. Okay, and then we will maybe initialize the register C right here. So with the virus, okay, start with the SOV. Okay, so and the VOV. So one of you maybe have no idea like because in lower level assembly or like this, so it will be fine. And we will start to doing the encipherment loop. So while we're checking, we're checking the register C. So when it's not and not equals EOV, and that's it. So they start. Okay. So they will compare like the cipher doing the XOR. So you know the XOR, the bit gate. So they'll measure if they're same, they will zero. If they're not matched, return one. Okay, like this. So every time they execute and they increase one by the encipher and then key one by one. Okay. And we have still several virus, so we quickly go through, and later after come back we will still like recap a little bit. Okay, and then the polymorphism of virus, including the virus, will change its set, and then it's like from the each time, so it will like insert itself into another program. So for this idea, we try to like prevent some signature detection. It may be change the signature instruction used to decipher the routine. Okay, so as in the instruction level, so they will substitute instruction in the algorithm, so they will have maybe a different algorithm to achieve the same purpose. You can do it. And truth keys, okay, can maybe make it exist. So if you remember truth keys we're using, so maybe some mutation engines like this. And after the decipherment, so some virus will load into the memory. So how it works, because the virus they are already encrypted. So maybe that these question routines are they're obfuscated. So it's like this. This one is called the polymorphisms virus. Okay, and just an example, maybe we have some instruction right here, different instruction. So with the different bit patterns, but they still have some like same effects. So maybe they adding 0 to the register, maybe they subtract 0 from the S register using X or no ops. So all this may be possible. And for the polymorphic virus, so they can also pick random from like among all these instructions. So it's really hard to follow. And then the metamorphic, this one will be similar, like just like the polymorphic, but the virus is just upscale. Okay, so when there are two instances of the virus, will look like different when we like open the program that when they load into the memory. So when they describe, so they may have like maybe two completely different implementation. Also, they have two completely different algorithm to protein same result. So it's really hard to tell. So this one is called the metamorphic. Okay, so here's a slightly different between the polymorphic and then also the metamorphic. So as well as like so it will try to change itself. Okay, so we change it from each time inside it and then the program. And this one is like if different way, like different every time when we load into the memory. So here's an example that we W95 or CMIS like virus. So they will distribute itself through the code being infected. So if you search or look in the file to infected, you see like maybe P 0.1. So right here, so maybe they will try to insert a jump instruction between each set non-jump instruction, or they can like infect with the unencrypted copy of a CMIS, or like be like 0.8 like here. So if the files have a section, so initialize data. So if there's voidable, so the infect files with the polymorphic encrypted version, CMIS. Otherwise, the infected file with the unencrypted copy of it. So like this. So in the first case, the virus can like expand in this section. So later it can insert the virus code. So as it decrypted and execute the code, So once we decode the code, it can preserve like register. So they can be like restored because in the like register. So on the execution stage, so it will allocate memory and put those like virus engine in. So it can create new instance. So we can transform the virus. That's how it looks. And just like the pause right here, so slide reflection, you see the mirrors this a long time ago, and the threads and landscape. So we always like try to remain like, up to date by checking activity region report and then backdoor worms or Trojan box. Keep changing different type, but just keep bear in mind. Sometimes like in behind actually similar things, but they change the packing, change the way they do it. Okay. And for this lecture, we kind of like stop right here. And we cover you at least like two things like Trojas and virus. You have a key concept, okay, but you're not really like covered in our quiz, so don't worry about that. And after we come back, so we'll continue to our computer room. Okay, so we still have pretty a lot. We're coming. There's two more lectures like to cover the malware. And thank you so much.